Hello everyone, today we will be starting on the oxides of nitrogen, and this is part of the acidic atmosphere topic. Most nitrogen oxides originate from nitrogen gas or in the air. Because we do have a lot of nitrogen gas in the air, making up a lot of the air is nitrogen gas, but some are produced when organic nitrogen fuels are burnt, and this is a man-made process. So let's look at some human sources of nitrogen oxides. So here we have human activity contributes to the creation of oxides through high temperature processes. Now what happens is, because we do have an excess of nitrogen and oxygen in the air already, in the presence of combustion engines which provide a lot of heat, it catalyzes a reaction between nitrogen and oxide to produce oxides of nitrogen. So this is one human source of nitrogen oxides. Other chief human sources include power generation, industrial processes in furnaces, and solid waste incineration. So we do have these different other sources that are from humans, sources of oxides of nitrogen. Molecules of nitrogen gas, which is denoted by N2, and oxygen gas, again denoted by O2. Now note that these two gases are diatomic, which means there are two atoms in a molecule, react at these high temperatures to provide nitrogen monoxide, a colorless gas. Now the reaction that is undergone here is N2 plus O2. Now again, these are both gases, so you must write your states down to give NO, which is a gas. Now you'd have to balance the equation because it's not balanced. We have two nitrogens on this side, we only have one nitrogen on this side. So if we put a 2 in front of NO, we get two nitrogens. We have two oxygens on this side, and we have one, but it's times by 2, so we have two oxygens on this side. So now all the atoms are balanced, which makes this a balanced equation. And this is what is happening and in the reaction here. So let's move on. We have NO gas, which is nitric oxide, which is insoluble in water. So it is not an acidic oxide. Now this is quite important because in last lesson we talked about acidic oxides such as sulfur dioxide, which is soluble in water. But nitric oxide, which is given by NO, is not soluble in water, making it not an acidic oxide but just an oxide. In nature, these high temperatures are provided by lightning. Now we're looking at natural sources now. So lightning is a natural source. So for the catalyst of the reaction we just did before of N2 plus O2 giving NO, this is usually catalyzed by lightning as when it's produced as a natural source. So here we have N2 reacting with O2 to give nitric oxide. Nitric oxide should not be confused with nitrous oxide. Now this is a key point. We have NO and also N2O. These are two different oxides of nitrogen. So NO is nitric oxide. And we have nitrous oxide, which is given by N2O. Now nitrous oxide can also be said as dinitrogen monoxide. So if you see there's two nitrogens and one oxygen, so it's dinitrogen monoxide. And it is commonly known as laughing gas and used mainly for anesthetics. So you can see the different uses of nitrous oxide in here. Now moving on, nitric oxide is produced by human bodies. So we produce nitric oxide, but in low concentrations. That is, that it poses no problem for us. So we do produce nitric oxide, and that is one source of nitric oxide naturally occurring. But it does not pose any problems for us, so it's all good. Now human production of nitrogen monoxide, which is nitric oxide, NO. Large quantities of nitric oxide generated by human activities pose various problems, and this is regarding the atmosphere. Once in the atmosphere, it can react rapidly with additional oxygen to produce nitrogen dioxide. Now, nitrogen dioxide here, it is an acidic gas. So nitrogen dioxide is an acidic gas, and it is quite toxic, and it poses danger in the atmosphere. So the reaction that happens is we have nitric oxide reacting with oxygen, the both gases, to produce nitrogen dioxide. Now again, always write the states down and also balance the equation. Human production of nitrogen monoxide, it is a reddish brown toxic gas. So it is toxic, which means that a lot of it in the atmosphere is very bad. That causes eye and respiratory irritation. So again, health hazards. It has health effects, and it can cause emphysema. So a lot of nitrogen dioxide in the atmosphere is not very good. People suffering from asthma are very sensitive to the effects of nitrogen dioxide on their lung function. So this is a very important thing. And nitrogen dioxide concentrations should always be monitored, because people suffering from asthma can have effects due to high concentrations of nitrogen dioxide. It can also produce inflammation of the lungs that can be fatal if exposure to high concentrations is prolonged. So these are a few different disadvantages of having large concentrations of nitrogen dioxide in the atmosphere. The World Health Organization, it's given as WHO, it has a goal, and the goal for air is 0.16 parts per million from 1 hour for 1 hour. So in 1 hour, only 0.16 parts per million of nitric oxide should be in the atmosphere, and 0.06 parts per million for 24 hours. Now let's look at this ppm unit that we just came across. ppm stands for parts per million. This equals to milligrams per liter. Now note, milligrams is a weight, while liter is a volume. So that means that you are going to give your answer in a weight and a volume. And you can also give it as ppm, which is parts per million. That means there are 0.16 parts in a million parts. So for example, we have 0.16 particles in 1 million particles, and it's a concentration. So if you come across either milligrams per liter, you can easily convert that to ppm because it's the same thing. Now, nitrogen dioxide reacts with moisture in the atmosphere or rain. Now, this is the similar process that we learned in sulfur dioxide. Remember, sulfur dioxide does react with the moisture or the water in the air? Well, nitrogen dioxide does a similar thing. It produces a weak acid and also a strong acid. The strong acid is nitric acid, which we have come across before. But the weak acid is nitrous acid, which is HNO2. Now, if we look at this, as seen in the reactions, NO2 plus water gives nitrous acid and nitric acid. This is the weak acid and this is a strong acid. Now we can also write it as this, where we have nitrogen dioxide reacting with water. It produces the nitrous acid, which is a weak acid, but this is ionized. Because it's a strong acid, it readily ionizes. So we have hydrogen ions and nitrate ions present in our solution. So these are two ways that you can write it. Again, always write the states down. Notice that the acid states are always aqueous, the water is a liquid, and nitrogen dioxide, of course, is a gas. And balance your equations always. Another reaction that can only occur in abundant oxygen is this, where we have nitrogen dioxide reacting with oxygen in the presence of water So this is the reaction. If there are a lot of oxygen in the air, this happens to produce nitric acid. Now this is a strong acid. Now this happens in equilibrium, so it is not a complete equation that goes this way. It's equilibrium, which means that it goes forward and backwards. So again, always balance your equation and write your states down. Now we have come to a table now. Here we're going to be comparing the properties of and sources of the oxides of nitrogen. Now we learned about 3 oxides of nitrogen. If you remember, we learned about nitrogen dioxide, which we just learned then. We also learned about nitric oxide and nitrous oxide. Now let's look at nitrogen dioxide. The name is nitrogen dioxide, given by the formula NO2, which is easy because dioxide making 2 oxygens and nitrogen. So NO2. It is red-brown in color, so it is red-brown gas, and it is acidic. So the natural sources of nitrogen dioxide is sunlight on NO and NO2, which means that the reaction NO plus O2, which is oxygen, produces NO2, but this only happens in the presence of sunlight. So usually during daytime, nitrogen dioxide is present. Again, this is a gas, and this is nitrogen dioxide, which is again a gas. So you can see, and you have to always balance the equation. We have 3 oxygens on this side, only 2 on this side. We would put a 2 here to get 4 oxygens on this side. And by putting a 2 here, we're balancing the equation because now we have 2 nitrogens, 2 oxygens giving us 4 oxygens here. 2 times 4 gives us 4. So we have 2 times 2 gives us 4, which means we have 4 oxygens on this side, and the equation is balanced. Now the industrial sources of nitrogen dioxide, the combustion of fossil fuels, especially in power stations and transport. So we have nitrogen monoxide again, reacting with oxygen gas to form nitrogen dioxide. So you can see how there are industrial sources as well as natural sources, but both have the same chemical reaction going on. So now let's move to the next table, which is where we are comparing dinitrogen monoxide, which is nitrous oxide, and nitrogen monoxide, which is NO, and which is nitric oxide. So dinitrogen monoxide is colorless, but it is not acidic, it's neutral. And the natural sources are usually soil, bacteria, or nitrogenous material. So we can see that even though it is neutral, it is produced as naturally from bacteria, because nitrogen is part of the protein component, so bacteria does produce nitrogenous material. Now, industrial sources, fuel for racing cars and dental analgesics, because it's a laughing gas. So these are some of the industrial sources of dinitrogen monoxide. Now we have nitrogen monoxide, which is nitric oxide. NO. It is colorless and neutral, but burns to produce acidic nitrogen dioxide. It is from soil, bacteria, and lightning. Again, lightning, because the nitrogen in the air reacts with the oxygen in the air to form nitrogen monoxide, nitric oxide, and this happens with a catalyst or the heat from lightning. And also it is produced in the combustion of fossil fuels in power stations and motor vehicles. Now in this section, what we learned was the oxides of nitrogen. We talked about the sources of nitrogen, both natural and industrial, as well as appearance and acidity. Now let's look at some questions that you may be asked from this section. Question number 6. Identify the main industrial source of both sulfur dioxide and nitrogen oxides. Now sulfur dioxide we did cover in last lesson, so you would have to kind of memorize, flip your book back to sulfur dioxide. We have 4 options here. We'll consider each option one by one. We have option A, bushfires. Now again, the word industrial source is very important. Bushfires are not an industrial source of these oxygens because it is a natural source. They happen naturally. So answer B is incorrect. Answer A is incorrect. Now let's go to answer B, which is dentists using anesthetic. Now that is a use, not a source. Note that dentists use anesthetic and they use nitrogen oxides for that, but it is not an industrial source. So option B is not the answer. Option D, metal smelters. Metal smelters do not release nitrogen oxide. We did learn it for sulfur dioxide when sulfide ores do release sulfur dioxide, but not for nitrogen oxides. So option D is not the correct answer. Let's consider option C, power plants burning fossil fuels. The burning of fossil fuels does emit both sulfur dioxide and nitrogen oxides. So power plants that burn fossil fuels produce sulfur dioxide and nitrogen oxide. So option C is the answer. Now let's go to question 7. Question 7 is not a multiple choice question. It says to outline natural sources of nitrogen oxides. The key verb here is outline, which means that you do have to name it, identify it, as well as give a description of it. So for example, here we have nitrogen dioxide and it says it outlines how it is produced. So when nitrogen monoxide reacts with oxygen in sunlight, this is produced. That's how it is produced. And we also have nitrogen monoxide, which is produced in the lightning and soil of bacteria. So lightning, when nitrogen reacts with oxygen in the presence of lightning, would produce nitrogen monoxide. And a third oxide of nitrogen is nitrous oxide, dinitrogen monoxide, and it is produced with soil bacteria. Now let's move on to question 8. Question 8 is a multiple choice question. What do the following equations that show the emission of oxides of nitrogen have in common? So we have two different equations here. We'll look at them separately. We have nitrogen gas reacting with oxygen gas to form nitrogen monoxide. Again, gaseous form. And then we have nitrogen oxide reacting with oxygen, but this time it's producing dinitrogen monoxide. In other words, nitrous oxide. So what do they have in common? And we have to see. So we have option A. They both happen in rain to make acidic, to make it acidic. Now they don't happen in rain, not both of them. So option A is incorrect. Now let's move on to option C now. They both produce harmless gases. Now they're both harmful gases, especially nitrous oxide. So option C is not the correct answer. If you go to option D, they both produce acidic oxides. Now they are not acidic oxides, they're both neutral. So the option D is incorrect. Now let's look at option B. They both involve combustion of nitrogen. Now what does combustion mean? Combustion is a reaction with oxygen. Now you can see that they're both reacting with oxygen and it is both nitrogen. So the combustion of nitrogen, yes, they do both involve the combustion of nitrogen. Therefore, option B is the answer. Moving on to question 9, it says, describe using equations examples of chemical reactions which release oxides of nitrogen. Now the key verb here is describe. The next to it says using equations, which means you have to use equations to get your full marks. And note that it says equations, which is the plural, which means you have to use more than one. Now let's see how you would answer this question. Nitrogen undergoes combustion to form nitrogen monoxide and dinitrogen monoxide. So you would give a brief description. but you would go into detail. Fossil fuels and biomass contain nitrogen, which is in protein, so they also burn to produce these oxides. Now you're going to give your equation. So what happens here? We told that nitrogen burns to form oxides. Nitrogen burns in the presence of oxygen to form nitrogen monoxide. Then we have nitrogen with oxygen again forming nitrous oxide, which is dinitrogen monoxide. Now we also have another form of combustion. Again, nitrogen undergoing combustion in the presence of oxygen forming nitrogen dioxide. So you can see the nitrogen undergoes combustion in 3 different ways to form 3 different oxides of nitrogen. Nitrogen monoxide burns to produce nitrogen dioxide. So you can see the nitrogen monoxide from here would burn in the presence of oxygen to form nitrogen dioxide. So it's simple and it shows step by step how nitrogen dioxide and oxides of nitrogen are formed. Now going to question 10, it says outline the chemical property of nitrogen oxides that has a negative impact on the environment. Now the key verb here is outline, which means that you'd have to outline it and show the negative impacts of having nitrogen oxides in the environment. Nitrogen oxides dissolve in water to produce acids. It is these acids that damage plants, animals, the soil and buildings. Now this gives a brief outline of what nitrogen oxides does. And in fact, it does produce acid rain, which damages plants, animals, the soil and buildings. So that brings us to the end of the section where we looked at the oxides of nitrogen. We looked at natural sources of the oxides of nitrogen as well as human sources. And we looked at few questions which gave us a great detail of these oxides of nitrogen.